Welcome back to Think Thrice. Today we're going to solve a nice little word problem. So the word problem we're going to solve today is the Great Bus Breakdown. So we have a group of travelers that are all going on a trip to a mathematical problem-solving convention. When they leave, there's an equal number of travelers on each bus. When they get halfway there, 10 of the buses break down, and the travelers are just redispersed so that there's one more traveler per bus. On their way home, another tragic bus breakdown happens, 15 more break down, and they add 3 total travelers to each of the remaining buses. All right, so our goal is to determine how many total travelers there are and how many buses were originally sent out. So if you'd like to give it a try, go ahead and pause the video and see if you can come up with your own solution. Otherwise, let's go ahead and look at my solution. So the first thing I want to do is I want to make sure that I'm defining my variables. So my first variable is going to be the total number of people. And I'm going to name that P. My second variable is going to be the total number of buses departing from the beginning point. And then my N is going to be my initial number of people on each bus. Okay, so if I'm looking at that first sentence up there, the one highlighted in red, it says when they leave, there's an equal number of travelers on each bus. So if I look at the total number of people and divide that by the total number of buses, that's going to give me the initial number of people per bus. Okay, so let's investigate that next blue sentence. So it says 10 of the buses break down. No problem, the travelers are equally dispersed on each of the remaining buses by adding 1 person. So that means that I have 10 less buses, so B minus 10. I have the same number of people, and my number of people per bus is going to be my original number plus 1. So if I rewrite that a little bit, let's substitute in that P over B, and now we have an equation that we can solve here. So let's look at this equation and see if we can get it in a different form. Let's try to solve for the number of people in terms of buses. So if I make this P over B minus 10 minus P over B, we have that equal to 1. Let's multiply both sides by B times B minus 10 to get those numbers out of the denominator. And that's going to leave us with P times B minus P times B minus 10 is equal to B times B minus 10. Let's go ahead and distribute. We're going to get P times B minus 10 is equal to B times B minus 10. A couple things happen there. This is going to be plus 10, negative, negative. So we're going to be left with P equal to B over 10 times B minus 10 in parentheses. Okay, so now let's take a look at that second equation, or that second statement in purple. It says 15 more buses have broken down, so our total number of buses is going to be B minus 25 now. So 25 less buses. And we're going to have 3 more travelers per bus, so our original number of people is still the same, but now it's going to be N plus 4 because it's the 1 that was added originally plus 3 more added. So let's do the same thing as before and rewrite this as P over B minus 25. Do some substitution to get that P over B and have that plus 4. We can use the exact same technique for solving as we did before. So let's make that P over B minus 25 minus P over B is equal to 4. That gives us P times B minus plus 25 is equal to B times B minus 25. A couple things cancel, and we're going to be left with P is equal to, that's 4. P is equal to 4B over 25 times B minus 25. Use the exact same solution technique as above. Now what we have are two statements where we have p as a function of b. P is a function of b above and there. So let's go ahead and set those two equations equal to each other. You get b over 10 times b minus 10 is equal to 4b over 25 times b minus 25. A couple of our b's cancel. And if we want to deal with whole numbers instead of fractions, I can multiply the whole thing by 50. So let's multiply our whole equation by 50. That'll get rid of those denominator terms. So now I'm going to have 5 times b minus 10 is equal to 8 times b minus 25. So let's distribute here. So we get 5b minus 50 is equal to 8b minus 200, which gives me that 150 is equal to 3b, and subsequently b, our number of buses originally, is 50. So our original number of buses is 50. Now we can just go ahead and plug that number into our original equation for our buses. So we had b over 10 times b minus 10, people as a function of the original number of buses, which is going to give us 50 over 10 times 50 minus 10, which is going to be 5 times 40. So our original number of people is 200. So what we've just done is we found the original number of people and the original number of buses when we departed. And these are our two answers. So hopefully you had fun with this one. Maybe you were able to figure it out by yourself. If you have another problem that you'd like me to try out, feel free to submit it, and it could be in a future video. If you enjoyed this content, please like and subscribe. And no matter what, go ahead and think thrice. Thank you.